So hello, everyone. Thanks for attending this session. My name is Kepa Iturralde. My colleague name is Danya. Unfortunately, we couldn't travel to Montreal because our flight was overbooked and we couldn't find a suitable rebooking of our flight. So this is a pity because it's always nicer to be with colleagues and in presence, but that's why we are recording this video. So the paper we will present is, the title is A Robust Pipeline for Facade Geometry Estimation Using AprilTags and Digital Imaging. The main author was Mr. Aravind Srinivasaragavan. Then we have Ms. Danya, myself, Kepa Iturralde, and Christoph Holst as a shareholder of where this research was achieved. We are working in a research project called ENSNER, European Research Project. Yeah, I will explain it now. This is the structure of the presentation. Well, we have introduction, objectives, methodology, optimization, results, conclusions, some recommendations at the end, references, and the acknowledgement of this project. Just to say a little bit more, what's the background of this research? We would like to automate, robotize, and digitalize the whole building renovation process. As you know, we need to, well, it's in the current building is, the majority of the current building stock is not properly insulated. It doesn't have any solar panels or any other renewable energy sources, and we would like to automatize that by using prefabricated elements, robotics in the prefabrication, robotics in the installation process, and so on. But for that, measurement is crucial, very important. We need to have very accurate measurement of the building, because instead, when placing all these prefabricated elements with robots or by manual means, there might happen collisions between the prefabricated modules. There might happen collisions between the pipes of the renewable energy might not fit. There might be also water leaks, and we cannot achieve airtight condition of the new envelope that we are placing on top of the existing building. So until now, the most reliable way or accurate way of measuring a building or the built environment was to use this kind of targets and a total station. And for that, we might need some sort of crane with an operator placing these targets and 2 operators measuring each of the retroreflective targets and naming them or measuring them in a CAD file with a tablet or whatever. What we propose is to use, instead of the retroreflective targets and a total station, is to use OpenCV technology with AprilTags, so we can measure by only using a camera instead of a total station. And well, you might think, oh, you still need to put these targets on top of the existing building. Yes, in another paper that we presented last year, we showed how we can place those targets in existing building with a UIB, and that was it's been quite successful also. So this measurement is interesting for urban, not only for building renovation, but for urban planning, also for energy optimization and heritage conversion. And maybe we forgot to say, it's also interesting for infrastructure, roads, tunnels, bridges, and so on. As I said, the traditional way of measuring is very time consuming, and we would like to make at least a time reduction of 50%, even more, 90% of the time. So the idea is that we put different AprilTags on top of the existing building. With one picture, we cannot measure the whole. Normally, if the building is considerably big, we cannot measure the whole building with only one picture, but we need to take different pictures and overlap these pictures and the AprilTags, so we can have a relative position of each of them. And that's what we will like to explain what we developed for this paper and this presentation. And now I will give the floor to Ms. Danya Liu.
Yep, please help me to click the screen for the goal. Yeah, so our goal here is to build a robust yet low-cost pipeline for 3D facade geometry estimation. And there are 3 key steps in our process. The use of the AprilTags as spatial markers. And the second one is to leverage the widely available digital imaging tools. And at the end, we would like to build an open source pipeline, and every component of the pipeline, from the image enhancement to coordinate reconstruction, is built by using the Python and open sources library. And this is not only ensure the transparency, but also make it easier for others to build based on our work, whether for academic or industrial or community use. Yeah, and here we provide a visual summary of the core methodology. On the left side, you can see a typical image of a facade with lots of AprilTags on it. And the middle image shows us the result after construct enhancement, which is a necessary step for when lighting conditions are not ideal. And finally, on the right side, you can see the successful detection of the tags using the AprilTags Python library. And this detection step will provide us with the 2D pixel coordinates and the tag IDs, which are essential for the next stage, estimating the 3D position of each tag. And here we can see to reconstruct the 3D coordinate, we need to first estimate the distance between the camera and each tag. And this is done by using a very simple and effective formula shown here. And we can see another formula here. This will allow us to move from pixel space to object space, essentially constructing the 3D layout of the tags in relation to cameras. But even with this accurate detection, the resulting is not that good. It will suffer from the distortions. So we use the plane fitting here, and we use the Thorny Alpha 7R for high solution imaging. And on the software side, we relied entirely on open source Python libraries, AprilTags for detection, and NumPy for computation, and SIGKit for the plane fitting. And we validate our approach by comparing the reconstructed coordinates with the reference ground truth values. And this confirms that even with a very simple setup like our cameras, the reliable 3D construction is possible by using our method. Next one. Okay. So to sum up, we presented a lightweight, flexible, and accurate pipeline for 3D facade geometry estimation. It doesn't require very expensive hardware or expert training, yet achieves good spatial accuracy and robustness.
Yes, I may add something to this in this slide. So basically, well, the results show that for now the technology that we developed can be competitive comparing to total station. Probably we will need to improve in the future some features of this technology. And as far as we know, there are also this kind of similar to these technologies, companies like well, total station manufacturers, they are already considering it for their future marketing and industrial development.
Okay, so in the future work, there are several exciting detections we would like to explore. First, we will integrating the serial visions for the project, and then we combine the pipeline with photogrammetry or SLAM algorithms, which can enable the full 3D facade reconstruction beyond the surfaces. And at the end, we are exploring ways to automate the tuck detection and alignment, possibly through dynamic tucks. And I believe that this addition will make the pipeline even more autonomous and suitable for more complex environments.
So thank you very much for this. Well, unfortunately, we cannot answer your questions there. I need to acknowledge the European Commission on the ENSNAR project. As I said in the beginning, this is only a small part of the project regarding the accurate measurement. And we are also working regarding the automation with robots in the manufacturing and on-site with the installation of the panels. So please keep in touch with us if you are interested. And you can also contact us in LinkedIn. And if you have any question, please feel free to send us an email. Thank you very much.
Thank you.
Thank you.